Welcome to part 2 of network analysis in project management. Let us see what is PERT and CPM. PERT stands for Program Evaluation and Review Technique, while CPM stands for Critical Path Method. PERT and CPM are project management tools which are used to plan the scheduling of individual activities that make up a project. PERT and CPM are used to determine the earliest or latest start and finish times for each activity in a project, the earliest and latest start and finish times for the entire project completion, and also the slack time for each activity. Let us see how we can determine the critical path in a network. The first step is called as forward pass. So in a network, we make a forward pass as described below. For each activity I, beginning at the start node, we compute the earliest start time ES. The earliest start time ES is calculated for each activity beginning at the start node. So what is ES? ES is the maximum of the earliest finish time of all activities immediately preceding activity I. ES is the earliest time an activity can begin without violation of immediate predecessor requirements. ES is 0 for an activity with no predecessors. It is important to remember that those activities for which there are no predecessors, ES is 0. The next time we calculate is earliest finish time. Earliest finish time equals to earliest start time plus time taken to complete the activity I, or duration of activity I. Earliest finish time represents the earliest time at which an activity can end or can be finished. What is the project completion time? The project completion time is the maximum of the earliest finish times at the finish node. So the project completion time is the maximum of all the earliest finish times at the end node of the network. Now, the second step in determining the critical path is called as backward pass. So we make a backward pass through the network as follows. We move sequentially backward from the end or finish node to the start node. At any given node J, we consider all activities which are ending at node J. For each of these activities Ij, we compute first the latest start time. Latest start time equals to latest finish time minus time taken to complete the activity Ij. Latest start time is the latest time an activity can begin without delaying the entire project. Then we calculate latest finish time, or LF. LF is the minimum of the latest start times beginning at node J. For the end node, this is the project completion time. Now, it is important to remember that the latest finish time LF for the last node is the same as EF of the last or end node. This is the latest time an activity can end without delaying the entire project. The step 3 in determining the critical path is calculating total float. Total float, also called as slack, equals to latest start time minus earliest start time, or latest finish time minus earliest finish time. A critical path is a path of activities from the start node to the finish node with zero slack time. So all the activities which have zero slack or float time are critical activities of the network. Let us look at this problem where activities of a project are given. For each activity, predecessor is given and duration of each activity in days is given. Let us solve this problem. We are now going to draw a network diagram for the problem shown in the earlier slide. After we have drawn the network diagram, we will do calculations at each node. So the first node of the network is node 1, which marks the beginning of the project. From node 1 emerges activity A having duration 6. Activity A ends at node 2. From node 1 emerges activity B having duration 4. Activity B ends at node 3. Activity A and B have no predecessors, so they are the first activities to begin, and activities A and B are concurrent activities starting from the same node. From node 2 emerges activity D. Activity D ends at node 5. From node 2 emerges activity E. From node 2 also emerges activity C. Activity B and C merge at the same node, that is node 3. Duration of activity D is 5 and duration of activity E is 1. Duration of activity C is 3. From node 3 emerges activity F. Duration of activity F is 4. Both activities E and F merge at the same node, that is node 4. From node 3 emerges activity G having duration 2. From node 4 emerges activity H, which ends at node 5. Activity H has duration 6. From node 4 emerges activity I. Activities G and I merge at the same node, node 6. From node 6 emerges activity K. Activity K has duration 5. From node 5 emerges activity J. Activity J has duration 3. Both activities J and K end at the same node, that is node 7. Node 7 marks the end event of the project. So the first node of the network diagram is node 1 and the last node of the network diagram is node 7. Once we have completed the network diagram, we are going to do forward pass calculations. Forward pass calculations are done from left to right. That is from the first node to the last node. In forward pass, we move from the first node to the last node. In forward pass, we calculate early start at each node. You can see in the green box that early start at the first node is taken as 0. So, early start at node 1 is 0. On the screen, you can see early start is presented in the rectangular box. Early start at node 2 equals to early start at the preceding node, that is node 1, that is 0, and duration of the activity, that is 6. So 0 plus 6 equals to 6. Early start at node 3. Now at node 3, two activities merge. They are activity B and activity C. So we are going to calculate early start for these two activities and take the maximum of these early starts. So for early start for activity B will be 0 plus 4, whereas early start for activity C will be 6 plus 3. Maximum of these two values is 9, therefore early start of node 3 is 9. Similarly, at node 4, two activities merge, activities E and activity F. So we calculate values of ES for these two activities, which are 1 and 13, and we take the maximum, that is 13. For node 5 again, two activities merge at node 5, activity D and activity 6. The early start are 6 plus 5 and 13 plus 6. So the maximum is 19. So ES for node 5 is 19. For node 6, again, we take maximum of 2 ES, early start for activity G and early start for activity I. So we have values 11 and 18. Maximum is 18. So early start for node 6 is 18. For node 7, again, two activities merge at node 7, activity J and activity K. Early start for activity J is 19 plus 3, 22. Early start for activity K is 18 plus 5, 23. Maximum is 23, so ES for node 7 is 23. Now we have calculated all the early starts at each node. So forward pass is now completed. Now we are going to do backward pass. In backward pass, we move from right to left, or we do calculations from the end node to the first node. In backward pass, we are going to calculate late finish at each node. In this diagram, late finish would be shown in blue oval. Now you can see in the node that late finish at the last node is equal to early start at the last node. For all other nodes, late finish equals to late finish of preceding node minus duration of the activity T. That means for node 7, late finish equals to early start at node 7, that is 23. Okay. Now for node 6, late finish equals to 23 minus duration of the activity, that is 5. So 23 minus 5 equals to 18. For node 5, late finish equals to 23 minus T, 320. For node 4, now at node 4, LF equals to 18 minus 5 equals to 13. At node 3, now we see at node 3, two activities are emerging, activities F and activities J. Now we have to calculate late finish for these two activities and take the minimum of these activities. Okay, so for activity F, late finish is 13 minus 4, 9. For activity G, late finish is 18 minus 2, 16. The minimum is 9. So late finish for node 3 is 9. At node 2, 2, you see from node 2, three activities are emerging. They are D, E and C. So we will calculate late finish for these three activities and take the minimum value. Minimum value here is 6. So LF at node 2 is 6. At node 1, LF equals to minimum of two values and that is 0. Now we have completed backward pass and we write down all the ES that we have calculated and all the LF that we have calculated at each nodes in the yellow table. In the earlier slide, we did forward pass and calculated early start or ES at each node, and we calculated backward pass and calculated late finish or LF at each node. On the screen, you can see the yellow table at the right bottom, which shows ES calculated at each node and LF calculated at each node. Now we are going to do calculations at each activities. So you can see the first column shows all the activities from A to K. The second column shows activities and beginning and end nodes. And in the third column, we write down duration of each activity, that is T. We will now calculate early start or ES of each activity. So take activity 1 to 2. For activity 1 to 2, the beginning node is 1 and the end node is 2. So we have to take ES1 here. So ES1 is 0. So early start for activity 1 to 2 is 0. Similarly, for activity 1 to 3, beginning node is 1, ES1 is 0. For activity 2 to 3, beginning node is 2 and ES2 is 6. For activity 2 to 5, beginning node is 2 and ES2 is 6. For activity 2 to 4, beginning node is 2 and ES is 6. For activity 3 to 4, beginning node is 3 and ES3 is 9. For activity 3 to 6, beginning node is 3 and ES3 is 9. For activity 4 to 5, beginning node is 4 and ES4 is 13. For activity 4 to 6, beginning node is 4 and ES4 is 13. For activity 5 to 7, beginning node is 5 and ES5 is 19. For activity 6 to 7, beginning node is 6 and ES6 is 18. Now we have calculated early start of all the activities. Now we will calculate early finish of all activities. So early finish of all activities equals to, you can see in the orange box at the top, early finish of an activity equals to early start of activity plus duration T. So for first activity 1 to 2, early finish equals to 0 plus 6, 6. For 1 to 3, 0 plus 4 equals to 4. For 2 to 3, 6 plus 3 equals to 9. For 2 to 5, 6 plus 5 equals to 11, and so on. We calculate early finish of all the activities. Now we calculate late finish of all activities. Now take activity 1 to 2. The end node is 2 and see LF2. What is LF2? LF2 is 6. So late finish for activity 1 to 2 is 6. For activity 1 to 3, the end node is 3 and LF3 is 9. For activity 2 to 3, end node is 3 and LF3 is 9. For activity 2 to 5, end node is 5 and LF5 is 20. For activity 2 to 4, end node is 4 and LF4 is 13. For activity 3 to 4, end node is 4 and LF4 is 13. For activity 3 to 6, end node is 6 and LF6 is 18. For activity 4 to 5, end node is 5 and LF5 is 20. For activity 4 to 6, end node is 6 and LF6 is 18. For activity 5 to 7, end node is 7, LF7 is 23. For activity 6 to 7, end node is 7, LF7 is 23. Now we have calculated late finish for all the activities. Now we will calculate late start for all activities. So you can see in the orange box above, late start of an activity equals to LF of activity minus duration T. So for activity 1 to 2, LF is 6, duration is 6. So late start is 6 minus 6 equals to 0. For activity 1 to 3, LF is 9, duration T equals to 4. So late start equals to 9 minus 4 equals to 5. For activity 2 to 3, LF is 9, duration is 3. So late start is 9 minus 3 equals to 6. And so on, we calculate late start of each activity. Now we calculate float of all the activities. Now formula for float is again shown in the orange box above. Formula for float or slack equals to late start minus early start or LS minus ES or late finish minus early finish or LF minus EF. So for the first activity 1 to 2, late start is 0 and early start is 0. So float is LS minus CS 0 minus 0 equals to 0. For second activity, float is 3 minus 0 equals to 3. For third activity, that is 2 to 3, float equals to 6 minus 6 equals to 0. And thus we calculate float for all the activities. Once we have calculated the float for all the activities, we note down activities with zero float. So here activities with zero float are activities 1 to 2, activity 2 to 3, activity 3 to 4, activity 4 to 6 and activity 6 to 7. These activities are shown in the network diagram in red. These activities are the critical activities of the network and the path connecting these activities in the network is called as the critical path. On the screen you can see a table which represents all the calculations which we have done in the earlier slide. We have done calculations related to earliest time and latest time of all the activities of the project. So we have calculated early start or ES of all the activities. We have calculated early finish or EF of all the activities. We have calculated latest start or LS of all the activities. And we have calculated late finish or LF of all the activities, and then we calculated total float of all the activities. Then we locate those activities for which total float is 0. So we find out the activities for which total float is 0. Here I have highlighted the activities for which total float is 0 in orange. Those activities which are highlighted in orange are the activities with total float 0. These activities are 1 to 2, 2 to 3, 3 to 4, 4 to 6 and 6 to 7. These activities for which total float is 0 are called as the critical activities of the project. So activities with 0 total float are the critical activities of the project. When you connect these activities in the network diagram, what you get is called as the critical path. So you can see in the network diagram, critical path is the path connecting all the critical activities of the project. In the network diagram, you can see critical path in the red. So critical path is the path connecting activities 1 to 2, 2 to 3, 3 to 4, 4 to 6 and 6 to 7. What is the maximum project duration? Maximum project duration is the maximum early finish or EF. So maximum early finish or EF is 23 at node 7 and that is the maximum project duration. Thank you.